Okay, everybody, I got 6:30, so we're going to get underway. Hope your day's been a good one so far. The plan for us today is we're going to wrap up chapter 1. Many weeks within this class, we're going to do, I'd say typically a chapter a week. So with this class, it meets 2 times a week. That gives us our division, meaning on a Tuesday and a Thursday. Between that, we'll do about a half a chapter each time. Some of the chapters we're going to extend a little bit more beyond that, but I'm confident tonight that we're going to wrap up the ideas here within chapter 1. So last class, we got started in looking at quite a bit of, I'd say, course logistics, and then some vocabulary that we use pertaining to matter. Tonight, the focus is going to be more on measurements and accompanying calculations. So last time, I had a poll question asking you if you thought this was going to be a hard class. And it occurs to me that sort of misses the point. You know, there's all kinds of things that we succeed at that are difficult. I'm going to ask this instead. In chemistry, even if the work is hard, I can learn it and succeed. So take a second, I'm going to send you this as a poll question. Okay, so in chemistry, even if the work is hard, I can learn it and succeed. Would you say that statement is not at all like you or very true of you? Take about 5 more seconds. Okay, I'm going to end the poll here. I'm not going to share the results on this one. But what I'd like you to do now within this one, I'm curious if you could add to the chat here. Don't do it right away. What I'm curious is if you pause for a moment, what's your reasoning? What's your rationale for this? And when I say add to the chat, I'll give you enough time to put in a sentence or two. Don't just put in 2 words like, I don't know, I'm a superhero or something. Take your time for a second. Give me a good rationale here. What's your reasoning for your score that you gave to this just a moment ago? And again, I'll give you time to get your thoughts together and add something to that. Let's take about 1 more minute. If you're still contributing, please continue on, do so. Continue on and wrap up your thought. Now, as the comments have come in within that, one thing I found one perspective that a student had, or several that I saw within that, was along this word succeed. You know, I'd say when the question was, well, what exactly do we mean by succeed? I don't want to have too many polling questions, but that's also, I think, a really good comment. You know, is success a grade? Is success the aspect of learning it. So in some ways, that's a variable that it's up for you to decide what success looks like. I found that the comments that folks have been contributing on this, very insightful. When I say this helps me learn a little bit about the class, it absolutely does, okay? Responding to surveys like this gives me a really good sense of the perspectives of the students within the course. So I really appreciate your thoughtful responses there. I'm gonna switch as far as polls now and ask some specific things. So I wanna give you an update on some class assignments, but I wanna connect this to stuff we talked about last time. So class assignments involve mastering chemistry. I'm gonna send you a poll on this one. When are the mastering chemistry assignments due? So, whoops, sorry about that. Select all that apply. When do we have mastering chemistry assignments due? Now, this is clearly information that's predominantly recall from last time. I mean, it could be any days of the week. So if you recall this information, I think you did a great job of attending to the information when it was shared last time, and you have a good sense of this aspect of when things are due within the course. Take about 5 more seconds. Sharing the results on that. So strong consensus that mastering chemistry assignments are due on Friday and Sunday. You nailed it, absolutely. I looked today as far as the first assignment, which is the Introduction to Mastering Chemistry. This was earlier in the day, and we're already at about 50% of folks having completed that one. Perfect score for having completed it. So great job. Your first assignment within Mastering is due this Friday. The one that's due on Sunday, which will include some ideas here from chapter 1. We already have students starting that one. I think after today's class, you're going to be in a great position to finish both of those assignments. You don't have to wait till Saturday night or late on Sunday or something. After today's class, I think you're going to be in a great position to finish both of those. I'm also really encouraged to see that the plan's going to be the same. Mastering chemistry is going to be on Fridays and Sundays. It's going to be at the end of the week in both cases as we move on. So I really like your awareness of that. How about the perusal assignments? Another polling question for you. So within perusal, when are the perusal ones going to be due? Check all that apply here. Now, as these are coming in, what I'm seeing is even stronger consensus. I think that's probably because this is something that a higher proportion of the class has begun working on. Take about 5 more seconds. Within that one, man, really impressive. Almost 100% consensus within both of those, for both of those days. Absolutely. Perusal assignments we have due before class on Tuesday and Thursday. Great job. Couple thoughts within perusal. Last time there were a couple questions, and I got some information from you all about challenges of using the program with an iPad. So I grabbed an iPad and I played with it a little bit to explore, to see what you were seeing. And this would be how I would use it. This would be my suggestion. So here's a picture I have of perusal open with an iPad. Now within perusal, you've got 3 different parts that it's trying to communicate. There's video content, there's this timeline along the bottom, and then there's this comment section. And so when you all remarked as far as, well, it was difficult to manage all 3 of those as far as fitting it on the screen when you were using an iPad, I agree with you. So this would be my approach. What I would be doing is I would be watching the video and focus initially on adding my own comments. if I'm watching the video on an iPad and I see a time when I want to add a comment, sure enough, I can click on add comment. It allows me then to add my own annotations. It will, it might have some blocking of the screen right here at the bottom. It will have some blocking, but I think that I would be going through initially simply focusing on adding my own comments as I step through. I would go through the whole video that way. Then what I would do after I've gone through the video, I would decide if I also then wanted to explore the comments of others. And when I say others, it could be other people that are in your class. It could also be my comments. Above the comment section, there's something that you can pull down to filter the comments. So if you want, you could just look at unanswered questions. You could look at only the instructor's comments, something like that. The way that I do with that is I click on then the timeline right at the start, and I use the arrows to step through that. So if I were using this with an iPad, I would probably do it in those two stages. And in fact, when I use Perusal, that's how I do it myself. When I use Perusal, I look at the video and I add comments and go through independently. Then I go back and I click on a comment right at the start and I use the arrows to step through it. So if you're using an iPad, that would be my suggestion to try to make the interface work for you. Another thing, sort of last logistical update here. You notice that within Perusal, I've started to add some optional resources. When I add it within Perusal, it's optional, it has this marking right next to it, optional. So that means it's not for part of your homework grade. This is where I'm going to be putting our class videos. I'm going to put them on the same day that the class took place. And I've also added a supplemental resource for dimensional analysis. I'm going to talk a little bit more about that tonight. So let's get started then on the content. So as far as where we're at, where we're going, on the left-hand side, this is sort of a roadmap of the chapter. So tonight we're going to be looking at some properties of matter and aspects of making and reporting measurements. When I look at the exam questions or the learning objectives that match up with this, a couple of the most difficult ones in the chapter are found here. Using significant figures and calculations and metric conversions, including density. Those are two of the more challenging parts. So I want to draw your attention to aspects that students oftentimes have trouble with. So often on questions that combine numbers with chemistry ideas in this course, I find that scores are lower. The stuff that we're going to talk about tonight, many of those do that. There's chemistry ideas and there's also some calculations that we're going to have to do. Now this idea that when we combine them, scores are often lower. Why do you think that is? Tell me in the chat. Why do you think chemistry problems that include numbers are more difficult? I'm curious on what your opinion is. So I'm seeing various comments there. I think some of them I can help you with this evening. The comment within here that I'm less willing to accept within this is a generalization. If you say, well, I'm bad at math. I don't believe that. I think that the math that we have involved in this class, you are good at that math. I think that that is not the key stumbling block. I think that you have the mathematical skills. But story problems always seem more difficult. Even if you're doing this back in the 8th grade, you could probably do the math, but when it's listed as a story problem, it's more difficult to figure out exactly what you're supposed to do with the numbers. And when you have a chemistry story problem, it becomes even more challenging because you need to know the chemistry part. You need to be able to apply those ideas to the mathematical part. Take it out of the chemistry domain for a second. Let's say you're looking at geography and you're looking at the French language. You might be great at geography, know all your state capitals, but if the challenge someone poses to you is, oh, let me ask you in French, what's the capital of California? Your success is going to go down Absolutely, because now you've got two different domains that you're seeking to negotiate. And a lot of times that's what I find within this one. I think you have the mathematical skills you're going to need. Let's see if we can add the chemistry to it so that you are not intimidated by the math part. Another thing that I find is on a test, when it's mathematical, you can't really look at the context to remove other choices. When you're doing a calculation, I mean, you go through and you come up with a number for your answer. So in some ways, I know that also hurts students. Now, if I want to turn this around to the positive, the good news, I am certain that you will get much, much better when you practice calculations involving calculation, when you practice questions involving calculations. This is one where I know you can absolutely see improvement. Practice and repetition really helps when it's involving calculations and mathematical skills. Another great thing is you get immediate feedback when you do a problem like this. A lot of times students will contrast a calculation with what they might call conceptual. With a calculation, you get immediate feedback right away. Did I look at that correctly or not? Was I able to set it up correctly or not? Both of these, that practice really helps and you get immediate feedback. These are both things that are going to help you as a learner. So let's try to view it as a positive. Now, within the pre-class video, I thought people were making really good contributions throughout. I spent a little bit of time talking about different properties, how they might be measured, and the corresponding common units. A couple of things I want to revisit here. First of all, some folks were asking me, well, what kind of things are we supposed to memorize? I would memorize these details right here. The definition that a cubic centimeter is 1 milliliter, I would make sure I have that memorized. That it's 2.54 centimeters by definition is 1 inch, I would have that memorized. I say that I would have those memorized. I think that those are very important bridges to go from one idea to another. And from one idea to another, it might be a bridge between the metric system and the English units. So both of these, I think, would be things that I would prioritize if I were you to memorize. Another thing I'd say within the units here and the properties, this relationship between temperature and energy, kinetic energy, what a thermometer measures, we got a whole chapter on that. So I really like the comments and observations people were making, but we don't have to overdwell on that. That's not going to be a large portion of what we have to do on our first exam. I think that if we have this perspective that we know what kinetic energy is, because it's related to the motion of our particles, and that if we know what the potential energy is, how that's related to the position of our particles, at least for now within chapter 1, we've got a really good start on those ideas. So I really like the comments and observations people were making in the space on this. Our goal is going to be to connect what the particles are doing with these descriptions of energy. And in chapter 1, we're just getting started on that task. We also looked a little bit at the resources that we might use if we're measuring the temperature or if we're transferring liquids. So when it came to the temperature and reading temperature scales, we're going to be using Kelvin scale and Celsius scale throughout the semester. Most of the start of the semester, we're just going to be using the Celsius scale. When we get to gases later on, we switch over and do more with the Kelvin scale. Fahrenheit scale, I don't think we're going to use at all. This idea on the glassware part, I thought that you all made some really good comments. I like this one where there's a careful reading and noted that when we were looking at this glassware, I like this observation that most of the glassware is used to deliver specific volumes. Deliver specific. The deliver part means that that particular glassware allows you to transfer a certain amount. A certain amount is going to come out of the glassware, whether it's a burette or a pipette. Those are used to deliver a certain amount. Now, if you have something like a graduated cylinder or a burette, you can transfer a variable amount. It doesn't always have to be a specific value. For a pipette only has one marking on it. When the liquid is up to that particular mark, that is the volume that you can now transfer out of it. A volumetric flask, it only has one line on it as well. But if a volumetric flask is meant to hold a particular amount. Within the lab, what you're going to use, you use all of these resources except the syringe, but all of these other ones are going to be ones that you'll use right at the start of the course. I also like some of the comments here on this question is, why is a beaker not considered volumetric glassware? As Megan points out, that it has only approximate markings, and it would definitely be a challenge to try to determine something that was in between these. I completely agree. Joseph was commenting and looking at the shape of this, thinking that it had a rounded bottom, which might make it more difficult. I see what he's saying. I never have seen a student make that comment. In this case, I'm going to disagree because I have other ones that are rounded as well, like a volumetric flask is rounded as well. And that really isn't the point as far as what makes something volumetric or not. Two more sets of comments I like. I like this one. Juliana's saying, I think a beaker would be less accurate because it's designed more for holding rather than actually measuring. I like that because, yeah, you will be using beakers, and there will certainly be times when you need to be holding a certain amount of liquid, but it's not for accurately measuring that value. And Ella's view within here, where there's a description of what takes place quantitatively and how close you can actually measure a value, I thought that was well said too. Now, when we're looking at the glassware here, one thing to note, a beaker is really inexpensive. A beaker is only $2 or $3. Volumetric glassware, much more. Volumetric glassware, it's exactly aligned with what you all were saying. You pay more with volumetric glassware because the care with which they put on the markings is much greater. Volumetric glassware that you're going to be using most frequently is going to be the burette, the pipette, and the volumetric flask. Within these, when you use them properly, and you're going to be trained to use them properly, they're going to provide accurate measurements that are also precise. Both of these terms, accurate and precise, those are technical terms that we're going to explore tonight so we know exactly what they mean. Now, we have resources that we can use for making measurements. I talked about just a few ones that you'll be encountering. We're going to be communicating our values using the metric system. Different prefixes are shown here, and I think you're experienced with the metric system. The ones that I want you to know initially are the kilo, centi, and milli. So doing things like kilograms, centimeters, millimeters, those are the prefixes that I want you to start with. So several folks had questions as far as, well, which ones should we memorize? Let's start with those three. Also, this question, well, do we need to memorize them? I would say you want to have them memorized. We're going to have a lot of information that you amass here. You're not going to be well suited to have to go back and keep looking up particular values. I think with practice, you're going to become very acquainted with these. So when I say, this question, should you memorize them? You don't lose by memorizing them, okay? So let's see if with practice we become familiar initially with those three. Later in the semester, we'll add a few others like nano, but things like kilo, centi, and milli, let's memorize those. And by memorizing them, know the relationship between them, how to convert from one to another. Now, the example that I initially used within the video for conversion was shown here. So I had a value expressed in scientific notation in centimeters and asked to convert that to kilometers. So within my shown work here, this was how I was trying to illustrate how dimensional analysis is used. How we're going to be canceling terms for the units when I see them both in the numerator and denominator, and then getting a value that we can then convert and discuss in terms of scientific notation. These are skills that we're going to have, being able to apply dimensional analysis to cancel units to convert from one unit to another, and to be able to get into and out of scientific notation. Now, I point out within the video that there are several examples within the e-text if you want more details on this. And these examples within here, I think really helpful. They work through a particular question, and then they have it interactive with a video where you can click on it to see more of an explanation. Now, In the video, I point that you could look to the e-text for more information. This is not a requirement. I mean, I'm not looking over your shoulder on that, just a suggestion. But I think the e-text is really closely aligned with the learning objectives for this class. So you can't go wrong by knowing what's in the e-text. So let me ask you this question, I'm curious. I sort of show here as a progression. I'm curious where you're at right now in terms of the e-text. So when I say a progression, maybe you've not tried to open it. You tried, but it didn't work. You opened it, you read a little bit and looked it over. You read it more closely, or you worked some problems. Let me send you this one as a polling question. When it comes to the e-text within Mastering, which of these best describes where you're at right now? Take about 5 more seconds. Okay, so this is where you fit relative to your classmates within here. If you're in the category of you attempted to open it, but it didn't work, I think I can help with that. I bet you it's the pop-up blockers that you have within your browser, and that's what's happening. If you've not attempted to open it yet, give it a try, because I want to make it so everybody's in the category of being able to use it as a resource. So if you haven't attempted yet, or if you're still having problems, give it a try and let me help you, because I want to make it so that you have this as a resource that you're going to be able to use within the class. Now, an example that I chose within the video, and it seemed like people were having some success with, is this one right here, converting between liters and meters cubed. Now, when I say I deliberately chose this example, I know when it comes to dimensional analysis, the most common mistake that students make. And I chose this one because it's right on that point. The most common mistake that students make when it comes to our dimensional analysis is when it comes to terms that are either cubed or squared. And that's what I was trying to bring up within this example. So notice I can convert from liters to milliliters. By definition, 1 milliliter is a cubic centimeter. I know that there's 100 centimeters for every meter, but crucially, I am not canceling centimeters and cubic centimeters unless I cube that term. And if I cube the denominator, I got to cube the numerator too. This is what I mean when it comes to using dimensional analysis with cubic units, or the same thing would apply with squared units. The way that I think about it here is, if I look at this cube itself, let's say it was 1 meter on each side, 1 meter by 1 meter by 1 meter. In order to get cubic meters, it would be 1 meter times 1 meter times 1 meter, or 1 meter cubed. Now I could also think about that instead of 1 meter as 100 centimeters. Now it would be 100 centimeters times 100 centimeters times 100 centimeters. That gets me to centimeters cubed. This right here, I know, is the most common mistake that I find when we have dimensional analysis questions. This idea of, will you see a question with cubic units? Absolutely. I am sure every time that we have a dimensional analysis question on a test, and the point is, can you do conversions? We always ask it involving cubic units. I saw this comment where I definitely did not get the answer right the first time because I didn't cube the meters over the centimeters. Now I know this for next time though. That's absolutely the response that I want. When I pose the questions within there, give it your best try, which you seem to be doing. And if you make a mistake and you can learn from it in a video, that's absolutely my goal. If I can then reinforce it in class so that you can then subsequently practice and get it right on the test, that's exactly what we want to be up to. So this example right here, if you have a specific question on this in the when it comes to cubic units, If you got a specific question, ask me in the chat right now, okay? Is there something that you want more details on this? Because I know that this is an important feature for us. Question about having to memorize conversions. I think you want to be able to memorize conversions like the ones that I'm showing right here. Conversions between liters, milliliters, the conversion between cubic centimeters and milliliters. Everything within here, I think, is a legitimate conversion that I think, if I were you, I'd have memorized and I'd be able to apply it. There was also a question about where can I find more examples? Hang with me on this and I'll show that to you. A question about, do you need to set it up this way? You don't, okay? We're only grading your answers. We're not grading your process. This one right here, this is another problem that I think is right on the same subject. It's a little bit more advanced. And overall, I found that people are having good success within this one. So this one right here, very classic story problem. It's including dimensional analysis. You're going to be using the numbers, but you got to see how they end up fitting together. So a couple of thoughts on this one. So you notice right here, it's got this 1.61 in advance in front of it. This is an end of chapter problem from the e-text. The end of each chapter, grouped based on topic, many, many very relevant questions. When you see ones that I cut and paste here that have this leading value, I'm getting them from the e-text. So that's also telling you that's a resource. If you want to find relevant questions, you can look in the e-text for it. This is what you'll find within the e-text at the end of the chapter. So you'll find different learning outcomes listed. The learning outcomes are the basis for your test. After the learning outcomes, you're going to find relevant equations from that chapter. And after that, many, many different exercises. Great resource for practicing. Now, within the e-text that you'll find, and this matches up the same as the book, recall that you can look at the menu for it. If I look at the end of chapter 1, I see many different exercise problems. Now, what I want to point out is if you go to the bottom, this would be at the back of the book. There's something called back matter. If you look within that one, in that section, there's different supplemental information. Most important, what you'll find is it's got the answers for the different problems. So by looking at the back of the book, and you can get to it within that menu, you're going to find the answers. It's usually for about half of the problems. It's the answers for chapter 1, answers for chapter 2. So when I pointed out that a reason that I think that you'll be able to do very well on problems involving calculations, recall you can practice and you can get feedback. The problems that I would look to practice are end of chapter problems. I'm going to be suggesting a few for you. And if you want feedback, you can always look to see the answers, okay? Now, this particular one is worked out. This was the problem that was posed. This, I would say, is a very advanced dimensional analysis problem. Very advanced because it's quite busy. You've got a lot of terms throughout, a lot of things to cancel. My strategy, if I were trying to go about these, I would probably think in my head first, rather than writing everything out, how do I get from where I have provided information to where I want to end up? What do I conceptually think of if I'm going from cubic feet to kilograms and I have some information here involving density? So the kind of things that are coming to mind is, well, I'm going to have to use that bridge between my English units and my metric system, because feet, that's in the English system, and I need to get it into the metric system. So right away, I'm thinking that would be a term that I'm going to have to use. When it comes to the English system, I would expect that you would memorize and know conversions between inches and feet. I don't think you will, I know you won't have to know, let's say, how many feet in a mile. But let's know the conversion factor between 12 inches or 1 foot. I think that you'd also be expected to know conversions involving time. Seconds, minutes, hours. Notice that I'm not including things like gallons. I'm not including things like acres. I'm not all these other things that get strange within the metric in the English system. So when it comes to the English system, let's know inches and feet, and let's know values of time, seconds, minutes, and hours. So this particular example right here, this is from work my colleague, Dr. Ricardo, has done. This is her worked example. If I was doing this, I'd do it a little bit differently. When I'm doing conversions between liters and milliliters, this is how I would be writing it out. This is just my own preference. I would be writing it as 1 liter is 1,000 milliliters and 1 kilogram is 1,000 grams. She's writing it as 10 to the third or 10 to the minus third. That's just how, this is how I would be setting it up. Personally, that's how I do my dimensional analysis when I'm looking to cancel units involving the metric system. Now, that work that I showed just a moment ago, that's a snippet from this video that I've posted from Dr. Ricardo, my colleague who also teaches general chemistry. This is a very detailed look at some examples involving dimensional analysis. I really like the way that she goes through it. So that's something that I've posted as an optional resource. If you feel like dimensional analysis is something that you really don't have the hang of yet, watch that video, and if you have questions, post it in there. I've already started to respond to some. That's a spot where we can discuss the idea. Now, when it comes to dimensional analysis, I gave a couple examples within the video. My goal tonight was to sort of show you additional resources and point out things to look at. But you notice within our setting here, this is not a setting where I can say, well, now let's practice them. That's something that when it comes to calculations like dimensional analysis is something that you're going to have to do on your own time. I'll point you to good examples to work on, but class is not going to be a great way for us to go through that. So when it comes to dimensional analysis though, give me some feedback. What's your current perspective? Would you say, is it relatively new and you're going to have to learn more and then practice it? Would you say you've seen it before, but you're going to need to practice it? You're pretty confident, but a few more problems would be helpful, or you're very, very confident and you think you can teach it. So when it comes to dimensional analysis, where are you at right now? Take about 5 more seconds for me. Okay, to let you know where you stand with the class, here's our distribution. So my interpretation or my suggestion here, if you're in groups 1 or 2, where it's relatively new and you might need to learn a little bit more and then practice, or you've seen it before, but you need practice. If you're in either groups 1 or 2, I think that this optional assignment, this optional video with Dr. Ricardo, I would absolutely point you in that direction. I think she does a great job of explaining it, and there's examples that you could work through within that. It's optional. You don't need to annotate it within Perusal if you don't want to, but I would definitely, if you're in the 1 or 2 camp, I would be starting by looking at that as a supplemental resource. If you're in group 3, you're pretty confident, you want a few more problems just to be sure, hang around. At the end of class, I'm going to give you some that I think would be good, relevant ones to work on. Now, let me add now some new ideas to this. When we have different properties, when we're talking about things like mass, volume, density, etc., we classify these as being either extensive properties or intensive. Extensive properties are ones that depend on the amount of the substance that is there. If it's intensive, it does not depend on the amount. I remember this by extensive, thinking, well, how much does the object extend in space? How big is it? If it extends in space and that's important, then it's extensive. If it's independent of the size, then it's intensive. Let me give you an example here. So you've seen this sim. So let's say we take a piece of wood, we drop it in water, it floats. Because the density of the wood is less than the density of the water. If I change the size of the object, notice the object gets bigger and smaller, the volume goes up and down, but look at the density. The density is never changing. This is telling me that mass is an extensive property, volume is an extensive property, but their ratio, the density, is intensive. The density never changed, even when the object got larger or smaller. So we need to know the definitions of extensive and intensive properties, and we're going to be using that vocabulary later this semester. Now, within that sim, I used it to play with a few different things, bring up a few different points. So this idea of how we could drop an object and with water displacement determine its volume, that's something we want to be aware of. In this particular one, as far as the kind of data that one could record, well, we have the mass of the block. We have its volume by knowing what the initial volume of the pool was, how much it was with the object, and by the difference between those, that would have been the volume of the object. And we could also calculate the density of the object, of the brick there. Mass divided by volume would give me the density. Now, I use this to apply it in a few different ways, because what I tried to do was to make a story problem that would be sort of illustrated with this visual. I wanted to do this to give an example of dimensional analysis or two. So within this one right here, the first thought was, given that data, could we calculate the mass in milligrams and express it in scientific notation? This was my work for that one. So I knew that the object had an initial density. I knew based on displacement what its volume was. And now notice how it would cancel. The kilograms would cancel with kilograms, liters with liters, grams with grams. I'd have a value now in milligrams, which I could convert to scientific notation. Similarly, the next one would be, what would be the volume of the brick in cubic inches? This would be an example, cubic inches. So I would have to have that entire term cubed once again. This was an example that was in the video, and I thought people were doing a really good job. This is, I think, a pretty advanced application. My goal within this one was practice once again involving cubic inches, a cubic conversion, and doing sort of a story problem when we had multiple things to cancel. If this part right here, I know I'm going quickly to show, oh, well, this is my answer within this. This would be something that doesn't hurt at all, that you could either annotate this and ask questions when I post it to perusal, or you could return to the previous video and see what you and your classmates were adding there. This idea here of looking at making and reporting measurements, we've talked about several things within here, but I want to bring in a few more ideas too. So the first one right here is this language of accuracy and precision. That's something that was brought up earlier in the class when I mentioned aspects of, if you use volumetric glassware properly, if you're trained to use it, it can be both accurate and precise. Accuracy, it refers to how close the values are to what they're supposed to be. How close are they to what the true value is? Precision is used different ways. One way precision is used, it's talking about how close together are the values. If we see this example up here, if you're trying to throw darts at the dartboard, well, you're supposed to get them right in the center. This example right here, I see all the darts right in the center, and there's a very narrow distribution. They're not very spread out. So I would say in this example, this is something with both good accuracy and good precision. Now, a couple thoughts as we're analyzing these. If we want to describe something as being accurate, we need to know what the value is supposed to be. In order to determine or gauge the accuracy of something, we need to be able to compare it to the right answer, what the true value is. If we don't have that information, we don't know if it's accurate or not. When we're looking at precision and we want to know how close together they are, there's different ways statistically you could do that. You might have taken a stats class or in a different one and explored something called the standard deviation. That's one way to communicate how close together the values are. On a test, if you're asked to analyze this, I'm not going to expect that you'd have to use the standard deviation. Usually looking simply at the range for how spread out they are, that's going to be sufficient. Let me share with you a couple different questions, a couple different ways that this can be asked that I've seen on exams. So first of all, if that top example represents good accuracy and good precision, take a second. How would you use the terms accuracy and precision to characterize the center dartboard and then the bottom one? So in both of those cases, see if you can apply those terms. Is the accuracy good or poor? Is the precision good or poor? So in both of these cases, or in all three of these cases, we know where the darts are supposed to be. They're supposed to be in the red region in the center. Because we know where they're supposed to be, we can talk about if it's an accurate, or if the accuracy is good, or if the accuracy is poor. If I look at that center example, I think it has poor accuracy. They're all offset. They're all in this other region, but it has very good precision. Look, they're very close together. If I look at this bottom example, I think it has very poor precision. They're quite spread out. And it's tough to say if it has good accuracy or not. A lot of times, if the results have very poor precision, it's difficult to say anything about the accuracy because the values are so spread out from each other. One way that I've seen these terms, accuracy and precision, applied on tests is given like a graphic like this. That's one way that I've seen. At the top right here, I'm listing what the learning objective is. We want to analyze data in terms of accuracy and precision. It could be visual data like that. Here's another way that I've seen it asked. And in fact, this is probably more typical. So this one says, looking at this one, it was from an exam, I know. Looking at the data set below, determine which student is more accurate. Determine which student is more precise. So we have multiple trials for each, multiple trials from each of the students. I'm going to read the title here. These are measurements of a 15.00 centimeter standard sample. The language on that, standard sample, means this is what the answer is supposed to be. If you know what the standard is supposed to be, you can comment on the accuracy. When I was mentioning as far as the precision, I wouldn't expect that you would have to perform something involving, let's say, a standard deviation. My suggestion would be, first of all, look at the range. So if I look at both of these students' attempts, and I'm just listing the range from the highest value to the lowest value, it sure looks like within this example that Sasha's results are closer to the 15.00 value. I would say Sasha's results are more accurate. When it comes to the precision, I think Nora's results are more precise. They're in a very narrow range, but they're further away from the 15.00 centimeter value, the true value. Tell me here within the chat, Do you think you'd be able to analyze data involving accuracy and precision when it's provided in a table like this? And in particular, if you got a question and you're not clear on a part, let me know. Now, when it comes to accuracy and precision and applying those terms, that's it, when I look at degree of difficulty, that's sort of at the bottom of the pyramid. Students do well on that. More difficult are ones involving significant figures. So let's move on to that part. When we're in this section, when we're looking at accuracy and precision, applying those terms, we also want to understand how to use significant figures in calculations. So first of all, we have some rules describing whether digits are significant or not. And you might ask, well, why wouldn't a number be significant? It comes down to our system. When we're expressing values, if it's 105, 212.2, when we're using our digits, the one that gets tricky is the zero, because zero can do two things. Zero can either be communicating a measured value, or it could be a placeholder. The fact that zero in our system does both of those makes it, when we're looking at our values, we have to be careful as far as identifying significant figures. Our rules that we have within here, the key thing is, what is the zero doing? Is the zero simply communicating the place, or is it a value that would have been measured? So if I look at this one right here, I've got different values listed. If I look at this first value, 2000, if I follow through the rules right here, the guidelines, this only has one significant figure. The only significant figure is the 2. These other trailing zeros, they're simply designating the place. They're telling me, oh, put that 2 in the thousands place. There's no reason for me to think that those would be measured values. How might I communicate that they're measured values? Compare that to the value right below it, 2.000 times 10 to the third. In scientific notation, this is also the value 2000. I don't need to have all of those zeros there to use scientific notation to say 2000. But if I am including all of those zeros there, it must be because I've measured them. I must be trying to communicate that that is a value that I've measured. The whole thing of significant figures is really a situation of how do we handle our zeros. So what I'm going to do within here, I've got different values here, and our goal is to figure out how many significant figures go with each one. What I'm going to do within this one, I'm going to show you my answers. And what I'd like you to do is in the chat, if there's one or so that you're confused with, tell me which ones you're confused with. So take your time, you don't need to race. If you're confused by one of these, tell me in the chat and I'll try to add more details. Okay, a couple of these as they're coming in. A comment was made for this very first one. Could you write that without scientific notation and try to communicate that it was a value of 2000 with all of them being significant? You could by placing the decimal point after it, but that's not really accepted practice, because that's really easy to confuse as a period in the sentence in some way. So if I wanted to communicate that as the value of 2000 with all of the values being significant, I think it would be much better to use scientific notation. The ones that I'm seeing initially come in where seeking a few more details are these two right here. So let's take a second and see what's going on with both of these. So this first one right here, 0.00015. I think it has two significant figures, the 1 and the 5. I think that these other zeros are being used to tell me where to place the values 1 and 5. I think that that's the purpose of those particular zeros. Those particular zeros are not going to then be significant. They're just telling me the proper place to place the 1 and the 5. I think that is different than 0.150, which has 3 significant figures. This 0 at the end of it, I think it's significant. I would not need to write that there unless I was trying to communicate that that was a measured value. A suggestion for you, consider whether you're able to get a value into scientific notation. If I were to write these in scientific notation, I would be writing this as 1.5 times 10 to the minus 4th, 1.50 times 10 to the minus 1st. In both of these cases, and in all cases, when you use scientific notation, the leading values here, those are the significant digits. The 1.5 times 10 to the minus 4, the 1 and the 5, those are both significant digits. 1.50 times 10 to the minus 1st, the 1.50, those are the significant digits. So this idea that if you can get into and out of scientific notation, then you're right away, you can determine the number of significant figures. I'm thinking to when my daughter took this class about 4 years ago, she was having trouble with significant figures. And I just stumbled upon that. I said, well, why don't you write in scientific notation? And she's like, oh yeah, that's easy for me. It didn't occur to me that that's telling you the answer, right? So if you were to look at this bottom one, I saw a question within that. I would write that as 2.3401 times 10 to the, well, that 2.3401, those would be the significant digits that I would be using, okay? So one skill that we want to have is to be able to interpret the number of significant figures. But that's not going to be the main thing that I think you'll see on a test. The main thing that you're going to see on a test is when you then perform a calculation involving significant figures. Now, when you're doing this, if you recall within my pyramid, this was at the very top of the pyramid. This is the lowest scoring topic in the chapter. It doesn't need to be, but this is the one that we need to pay special attention to. We have two sets of rules, and I know this is what makes it difficult. We have one set of rules when we're doing addition or subtraction, and another set of guidelines when we're doing multiplication or division. Students are much better at multiplication and division, and they get messed up with addition or subtraction. So let's start and try to get clear on how do we do the addition and subtraction part. Here's a scenario. So about 2 years ago, I visited London. No joke. This is right outside the Tower of London. So there I am, and I had to get a picture next to Ted's Fish and Chips. I ate a lot of fish and chips when I was in London. But anyways, I was there 2 years ago. Now, in London, I visited the Natural History Museum, and they had this great dinosaur exhibit. Now, it said that the dinosaur was 35 million years old. How old is the dinosaur now? I mean, I was there 2 years ago. So would we say it's 35 million plus 2? Is the dinosaur 35 million in 2 years? Or is it still just 35 million years? I think it's still just 35 million years. It comes down to how do we handle significant figures with addition and subtraction. It does not matter if I saw it 2 years ago, 3 years ago, 10 years ago. When I look at this, I'm interested in the place. I'm interested in looking at the decimal place and, in a sense, the least useful as far as the significance, That's what I'm stuck with. I have to report that it's still 35 million years old, because that millions place, that's what's restricting the manner in which I report the value. When I'm doing addition and subtraction, my strategy is I need to stack them up and then examine the precision from there, examine the significance from there. When I am doing addition or subtraction, if it's listed to me like this, what I'm going to do is I'm going to stack them up. I'm going to place the ones over the ones, the tens over the tens. I'm going to stack them up based on where the decimal point would be. I'm not just going to take my calculator, I'm going to write out this process. Within that setup, would you agree with me that 312,520, the 2 is significant, but the 0 is not. The 0 is just holding the place. Now, when I do my calculation, this is what I would get when I added them all up. However, I can only report this to the tens place, because this top value right here, it's only significant to the tens place. That ones place was just a placeholder. I could keep all of the values when I calculate it, but when I'm actually going to report it, then it would only be reported to the tens place. When I'm doing addition or subtraction, it's all about the place. It's not the total number of significant figures. It all has to do with the place. And the least useful, the least informative, something only being to the tens place, that's what restricts me. That's the key thing we want to see when we're doing addition or subtraction. I'm going to have another example or two for us to practice. When we're doing multiplication or division, students usually do a lot better with this. This is now not about the place. This is about the number of significant figures. So if I were to take this example right here, I plug it into my calculator, this is the value that I get. It's going to be limited by the least number of significant figures that I'm using. 32.50 has 4 significant figures. 64,300 has 3. So if I needed to report it, this would be then what the value would end up being. Now, a skill I want us to have that we're going to use. What if I wanted to do this calculation, but I didn't want to round it because I was going to use that value again? I would give myself some kind of indication. So that's what I'm showing here. I'm taking the entire value that came out of the calculator, but I'm designating in bold where it is in terms of its significance. That's a skill that we're going to want to have when we're doing multiple steps in our calculation. Let me give you an example here. So when we're using significant figures in calculations, we first of all have to make clear what rules apply. Are we doing addition or subtraction? In that case, we're going to stack it up. When we have multiplication or division, it has to do with the least number of significant figures. When we're doing these and we have multiple steps involved, we're not going to round until we reach the final step. We want to pay attention to the significant figures along the way. We want to keep track of them, but we don't want to round anything until we reach the final step, because with rounding, you're going to lose information. One more feature to add, some numbers that you're going to find are exact numbers. An exact number is either defined that way or it may be exactly counted. Okay, so what do I mean as far as exact numbers if they're defined that way? 2.54 centimeters equals 1 inch is defined that way. It has an infinite number of significant figures. That is the absolute definition. So that will not be limiting my significant figures. What else would be an exact number? If I'm doing a metric conversion between grams and milligrams, that will not limit the number of significant figures I have. It's defined that way. It's not something that is measured itself. This idea of being exactly counted, that's usually relevant if you have a very small number of things that you're counting. If you're talking about fingers on your hand, you can exactly count that. There's not going to be any uncertainty in that. If you were to talk about the number of people in Ohio, now I don't think you could exactly count that. you'd have to do some kind of statistic sampling. So just because something is a number, you have to think to yourself, well, how would you actually go about measuring it? That's what it means to have it be exactly counted. This was an example that was, I believe, in the video on this. This is how I would go about answering this one. So this kind of question right here, I would call this a mixed operation significant figures. Mixed operation, it's combining both either addition or subtraction with multiplication and division. This type of problem right here, really typical of what you'd see on a test. Really typical. So this is how I would go about it. I see that I have something involving subtraction. I want to stack that up. I see that I have something involving addition. I'm going to stack that up. And when I say stack it up, I'm putting decimal point over decimal point, and I'm using that to determine the number of significant figures. If I look at this example here on the left, in both of those cases, it goes to 3 decimal points. So my answer then can go to 3 decimal points. The one on the right, I have an example going to 2 decimal points and going to 3. So I'm going to be limited and I can only go to 2 decimal points. This would be my first step when I'm doing the addition and subtraction. I'm going to stack it up within my analysis. Next is I'm going to take those and I'm going to be doing a multiplication. This has 3 significant figures. This has 1, 2, 3, 4 significant figures. So my answer is going to end up having 3. Notice I didn't round this value. I took the whole term, 48.352, but I put in bold to designate to myself which values were significant. That's how I came up with my answer. Now, quick thought within here. When these questions show up on tests, notice that the answer has 3 significant figures. If you look at the provided information, well, none of these have 3 significant figures. It was only within the process as we followed through the different steps that led us to the correct number of significant figures. I know that students many times, they simply think about the rules for multiplication and division, and they say, oh, well, it would be a lot quicker if I just applied those. We have to be careful when we have aspects of addition and subtraction as well. Okay, I'm going to pause for a second within this one. If you have a question based on what's on the screen right here, ask me in the chat on this. So if you have a question based on what's on the screen, let me know. Is there a part that you still don't understand? So Madison says, I still don't understand the 2 part. I'm reading that to say that this trailing value right here at the end. So in terms of doing the process, when I was adding it together, I had something with 2 decimal points and something with 3. So I can only have 2 decimal points within my answer. So within that one, I would keep all of the values that the calculator gave me, but I would recognize that it was only going to be good to those 2 decimal points. The rules here for addition and subtraction, that's the key part that I know. Oops, sorry about that. Let me work another example, okay? Here's one, this is exactly, we had off a test before. This says, perform the indicated arithmetic and report your answer to the correct number of sig figs. This is another example, mixed operation significant figures, okay? What I'd like you to do is see if you can get started on this, okay? Let me give you about 3 or 4 minutes, okay? Let me give you a few minutes to set up, how would you begin working on this? And then I'll show you my work and we'll see if we can get it together, okay? Grab a pencil, grab something, see if you can begin setting this up. And then we'll compare our work. So when I say see if you can get started, I'd say first step, let's recognize we have a subtraction and an addition. Those are going to be our first steps that we're going to seek to perform properly. Okay, let's share some work here. I'm seeing most of the answers around either A or B. So I think the key step is to see where does it take us when we do the addition or subtraction. So this would be me stacking up the values. So first of all, they're all in the same units. They're all in meters. So I don't have to do any other conversions there. If I do subtraction of 25.523 minus 17.63, I think that I can only report that to 2 decimal points. 25.523 minus 17.63 is 7.893. That last value of 3, yeah, I like to see it there. I could keep it for my subsequent calculations, but I can't count it as a significant figure because I was only good to 2 decimal points. That's my rule for addition and subtraction. If I look at when I did my addition on the right-hand side, 1356 plus 3.2, 1359.2. I can carry along that value, the 0.2, but I'm not going to use it when I consider my final answer because I'm only good to 1 decimal point. This is the key step that I have to do when I'm seeking to answer this, because now I can see that I'm going to be multiplying something with 3 significant figures and something with 4 significant figures. So my answer now will have 3 significant figures in it. This is the key part, and I know this is a stumbling block, is how do we handle addition and subtraction? So tell me within here, in the chat within this, do you see, if you're still confused, because I think this is the crucial part. Any questions on getting to that part, the addition, subtraction? So this value, I'm seeing two things that I would say that are related. This idea of this analysis here on the left-hand side, I'm combining two different ideas. So my first idea is I'm not going to round at this point. I'm going to keep all of the information that I have. So that's why I have all of the information that's showing up following the operation. But more importantly than that, I only have this value good to 2 decimal points. Because when I set it up based on the decimals lined up over each other, it's only good to 2 decimal points. That was my rule when I was doing addition or subtraction. I stacked them up that way. So in both of these cases, these would be the values that I would then use when I'm doing my multiplication. I would say that my final answer is going to have 3 significant digits. So those that were saying that the answer was going to be B, I agree with you on that. And the crucial step on here is going to be how we stack it up when we're doing addition or subtraction. Okay. Let me jump ahead here because I want to get to a couple more points. So a couple more points. At the end here, I want to point out a couple suggested problems. So when I mentioned that there's things at the back of the textbook that would be useful to look at, these are ones that I think are directly aligned with what we were talking about tonight. So this question 1.53, I think this is a really good example for you to begin to apply to see if you know what's going on based on these topics. These are using conversions and going between different sets of units. Milligram to kilogram, kilometer to foot, cubic inches to cubic centimeters. These are all really good examples. I think you could, you should be able to do these without looking up anything else. Millimeters to nanometers is fine, but I don't think nanometers is a value that you would need to know right now. So based on what we talked about, this would be a good thing to seek to apply your knowledge. I have 2 sets of ones that are based on dimensional analysis. So a quick thought here. Within the textbook, it takes at the end of chapter, it will take, and it usually will have 2 sets of questions that are on the same topic. So that's why you see 1.55 and 1.56. They're both on the same topic. The topic is dimensional analysis. When you look in the back of the textbook, usually the answers will be given for one of them. It's usually like the odd set. But if you want to have practice, I like the way that the textbook gives you problems that are in both paired together. So it gives you plenty of to look at and to practice within the same theme. So as I looked at these questions, couple thoughts. If it's 1.55B, this included a conversion into gallons. You're not going to have to convert into gallons without having information provided. That's an English unit that you wouldn't have to know. When I look at the bottom here, question C, that would be a really good one because look, it's within cubic units. I think though that's a skill that I mentioned we want to have. So I think that would be a really good example too. The most difficult one in the set, I think if you want to challenge yourself, would be 1.56D. So if you were in the category when I said, well, how do you do on dimensional analysis? If you said, well, I think I'm pretty good, but I want to practice a little bit more to be sure, try these problems, okay? 1.55 and 1.56, great examples to see, are you really proficient at dimensional analysis or not? Other skills that we worked on doing calculations involving significant figures. Here's a couple examples for that one. Notice there's a combination of addition and subtraction, and then also multiplication and division. And then the final set of skills that we looked at were applying terms like accuracy and precision when we had some experimental data. And that's what was taking place right here. And with that, I think we got a really good overview for the different ideas. Notice once again, as far as the ideas that are typically more difficult, significant figures and calculations, that's what we were looking at towards the end of class here. I think that would be one for everybody. You'd probably want to practice that to make sure you're proficient on that. overall though, I think we're definitely moving in the right direction. I'll hang around if you got any questions, and I really appreciate you spending some time with me.